Imagine for a moment that you are floating in the deepest, quietest void of space, far removed from the distraction of planets and the brilliant glare of stars, drifting in a silence so profound that it feels like a physical weight upon your consciousness, a velvet blanket of absolute stillness. In this place of tranquility, where the temperature hovers just above absolute zero, you are bathing in the oldest light in the universe, a faint, omnipresent glow that has been traveling towards you for nearly 14 billion years, touching every point in the cosmos simultaneously like a gentle, timeless breath. This is the cosmic microwave background, the cooling afterglow of the Big Bang itself, a relic radiation that permeates the darkness between galaxies and serves as the ultimate horizon of our observable history. For decades, cosmologists and astronomers have looked upon this mottled tapestry of microwaves as the final curtain, a shimmering wall of fire beyond which we cannot see, marking the absolute beginning of time and space, the moment when the clock of the universe began to tick. We are told that before this moment there was nothing, no space to occupy, no time to pass, simply a singularity of infinite density and temperature, where the laws of physics, as we know them, dissolve into mathematical nonsense. But as we drift here in the quiet dark, let your mind expand beyond that horizon, pushing past the edges of the known map to ask the question that has haunted humanity since we first looked up at the night sky: what happened before the beginning? It is a question that seems to defy logic, like asking what is north of the North Pole. Yet in the hushed corridors of modern theoretical physics, a new whisper is growing louder, suggesting that the Big Bang was not the start of the story, but merely a chapter change, a violent but rhythmic transition from a previous eon into our own. This is the realm of cyclic cosmology and the pre-Big Bang universe, a landscape where time may stretch back infinitely, where our cosmos is perhaps one of many breaths in an eternal lung, expanding and contracting, dying and being reborn in a majestic, unending cycle. To understand these echoes of a time before time, we must first attune our senses to the cosmic microwave background itself, understanding it not just as static on a radio telescope, but as a fossil record, a frozen map of the universe when it was merely 380,000 years old. Before that time, the universe was a hot, dense soup of ionized plasma, a blinding fog of protons and electrons that trapped light within it, preventing photons from traveling freely. The universe was opaque, a glowing cocoon holding its secrets close. It was only when the cosmos expanded and cooled enough for electrons to bind with protons, forming the first neutral hydrogen atoms, that the fog lifted and light was finally unleashed to stream across the void, stretching and cooling over billions of years into the faint microwave radiation we detect today. This event, known as recombination, defines the surface of last scattering, the visual limit of our universe. When we look at the cosmic microwave background, we are seeing the universe as it was at the moment the fog cleared, revealing a baby picture of the cosmos speckled with tiny temperature fluctuations, hot and cold spots that represent the seeds of all future structure. These minute variations, differing by only 1 part in 100,000, were the gravitational wells where matter would eventually pool to form the first stars, the swirling galaxies, and the vast cosmic web that structures the universe today. Standard cosmology tells us these fluctuations arose from quantum jitter during a period of rapid expansion called inflation, which occurred in the tiniest fraction of a second after the Big Bang. However, as we gaze deeper into this ancient light, we begin to see anomalies, strange patterns, and unexpected alignments that the standard model struggles to explain. Subtle hints that perhaps the seeds of our universe were not sown by random quantum chance, but were imprinted by something that existed before. Imagine throwing a stone into a still pond. The ripples expand outward, carrying information about the impact. Now imagine that before the stone hit, the water was already churning from a previous disturbance. The new ripples would mix with the old, creating a complex interference pattern that carries the memory of both events. This is the essence of the search for echoes before the Big Bang. Physicists and cosmologists are scrutinizing the cosmic microwave background for these interference patterns, looking for concentric circles, cold spots, or polarizations that could be the ghostly signatures of black hole collisions from a previous universe, or the bruising impact of a neighboring universe colliding with our own in a higher dimensional bulk. It is a concept that induces a sense of vertigo, a realization that our 14 billion year history might be a mere blink in an infinite timeline. We are venturing into a domain where the fabric of spacetime is not a static stage, but a dynamic, evolving entity that can bounce, loop, and perhaps even remember. As we prepare to dissect these theories, from Roger Penrose's conformal cyclic cosmology to the brains of M theory and the loop quantum gravity bounce, let the vastness of these ideas wash over you, not as a source of anxiety, but as a comforting reminder of the grandeur of nature. We are exploring the possibility that the universe is not a linear sprint from nothingness to oblivion, but a rhythmic, eternal dance. The light that touches our detectors today may carry the encoded messages of a forgotten ancestor universe, a cosmic heritage written in the language of radiation and gravity. We stand on the precipice of a paradigm shift, looking at the faint glow of the Big Bang and asking if we are seeing a birth or merely a reawakening. The silence of deep space is not empty, it is pregnant with history, vibrating with the residual energy of events that occurred before our clocks began to run. In this journey, we will walk the fine line between rigorous astrophysical observation and the profound philosophy of origins, seeking to read the ripples in the oldest light to find the signature of what came before. So, let your imagination drift backwards, rewinding the expansion of galaxies, watching the stars dissolve back into gas, the gas compressing into plasma, the plasma shrinking into a point, and then, crucially, looking through that point to the other side. There, in the mathematical mists of the pre-Big Bang era, we may find that the universe has no beginning and no end, only an endless transformation, a perpetual state of becoming that echoes the very rhythm of our own breathing, in and out, expansion and contraction, forever and ever. To move beyond the traditional concept of the Big Bang as a singular point of creation, we must confront the mathematical monster that lives at the heart of our current models, the singularity. In standard general relativity, if we rewind the expansion of the universe, we eventually reach a state where all matter and energy are compressed into a point of zero volume and infinite density. At this point, the equations of Albert Einstein break down, providing no information about what happened before or even how the physics could function in such an impossible state. For many years, this was seen as the literal beginning of time, but many modern physicists find the idea of an infinities in nature to be a sign that our theory is incomplete, rather than a physical reality. This has led to the development of the Big Bounce theory, a radical departure that replaces the jagged edge of a beginning with a smooth, rhythmic transition. Imagine the universe not as a balloon being inflated for the first time, but as a lung that has been breathing for eternity. In this framework, the Big Bang was not an explosion from nothing, but a dramatic rebound from a previous period of contraction. This is often explored through loop quantum gravity, a theory that suggests space itself is not a smooth, continuous fabric, but is instead made of tiny, discrete loops or atoms of geometry. As a previous universe collapsed under the weight of its own gravity, it eventually reached a density so extreme that these atoms of space could no longer be squeezed. Instead of collapsing into a singularity, the fabric of space exerted a powerful repulsive force, a kind of quantum pressure that caused the universe to bounce, triggering the expansion we observe today. This quantum bounce acts as a filter, where the laws of physics remain intact and the universe passes through the transition like sand through the neck of an hourglass. This model suggests that the history of the cosmos could be a series of cycles, or aeons, each lasting trillions of years. In such a cyclic universe, the beginning is redefined as a local event, a transition from one phase to another, meaning that our current universe might be the recipient of a cosmic inheritance. The entropy, the matter, and even the fundamental constants of physics might be passed down from the previous cycle, albeit in a highly processed and altered form. There is a profound comfort in this image, the idea that the universe has survived an infinite number of these transitions, and that our current existence is part of a grand, ancient rhythm. Some models, like the Ekpyrotic theory, suggest that this bounce is triggered by the collision of two branes, three-dimensional worlds floating in a higher dimensional space, coming together and drifting apart in a slow, majestic pulse. In this scenario, the energy of the collision is what fuels the creation of matter and radiation, setting the stage for the next period of expansion. As we contemplate this, the scale of time becomes almost incomprehensible, stretching back not just billions of years, but through an infinite sequence of prior universes. Each bounce would leave the cosmos slightly different, perhaps even refining the laws of nature over vast stretches of time. This perspective shifts our role from being accidental inhabitants of a one-off explosion to being part of a persistent, self-renewing system. The Big Bounce avoids the logical paradox of something from nothing by suggesting that there has always been something and there always will be. It invites us to see the expansion of our current sky as the momentum of a previous collapse, a cosmic recoil that is still playing out across the billions of light years of the observable horizon. As we settle into this idea, the frantic energy of a bang is replaced by the steady, reliable beat of a bounce, a heartbeat that defines the life of the cosmos itself. As we examine the faint, ancient light of the cosmic microwave background, we are searching for more than just random noise. We are looking for the geometric ghosts of a universe that preceded our own. One of the most provocative theories in this field is conformal cyclic cosmology, proposed by Sir Roger Penrose, which suggests that the distant future of our expanding universe actually becomes the Big Bang of the next. In this model, as the universe continues to expand for trillions upon trillions of years, all matter eventually decays into radiation, and black holes evaporate through Hawking radiation until the universe is filled only with massless particles. Because massless particles do not experience time or scale in the same way that massive objects do, the geometry of an infinitely large, cold, and empty universe becomes mathematically identical to the geometry of an infinitely small, hot, and dense Big Bang. This transition between eons might leave behind subtle, physical traces that we can observe today. Specifically, the theory predicts the existence of Hawking points, extraordinarily high-temperature regions in the cosmic microwave background that could be the residual heat from the evaporation of supermassive black holes in the previous eon. These points would appear as faint, circular anomalies in the temperature maps provided by satellites like Planck. While mainstream cosmology often attributes such features to random fluctuations or instrumental noise, the persistence of these patterns suggests a deeper story. Imagine the universe as a series of nested Russian dolls, where each new shell bears the faint indentations of the one it encloses. By analyzing the polarization of this light, scientists hope to find concentric rings of gravitational waves that would have been generated by the collision of black holes in the era before our own. This search requires an incredible degree of precision, as the signals would be buried under layers of cosmic dust and local radiation. As we descend further into this quiet world, you may feel your breathing begin to slow, a quiet reminder to subscribe and find your peace with us. The possibility that we are seeing the exhaust of a prior universe transforms the night sky into a vast archaeological site, where every photon is a potential artifact from a time when our sun and stars did not yet exist. These ripples do not just represent the birth of our space and time, but the legacy of an ancient, cooling cosmos that finally reached its end and, in doing so, paved the way for our beginning. The mathematical elegance of these models lies in their ability to resolve the paradoxes of entropy and the arrow of time, suggesting that the universe finds a way to reset its complexity while maintaining a structural memory. As we gaze at the mottled blue and orange maps of the early universe, we are not just looking at the past, we may be looking at the distant future of another world, a cycle of life and death on a scale that humbles the human spirit and invites a deep, contemplative stillness. The transition from a collapsing universe to an expanding one requires a bridge that spans the most extreme conditions imaginable, a regime where the smooth curves of general relativity must bow to the jittery, probabilistic nature of quantum mechanics. In the heart of this transition, we find the concept of loop quantum cosmology, which provides a mathematical framework for how a bounce actually occurs without the universe crushing itself into a point of non-existence. To understand this, we must visualize space not as an empty container, but as a granular fabric made of nodes and links, forming a spin network that defines the geometry of our world. As the previous universe contracted, the density of energy and matter increased, forcing these fundamental units of space closer and closer together. In classical physics, there is no limit to how small things can get, but in the quantum realm, there is a fundamental unit of area and volume known as the Planck scale. When the universe reaches this critical density, roughly 10 to the 94 kilograms per cubic meter, a new kind of physical force emerges: quantum repulsion. This force is a consequence of the Heisenberg uncertainty principle, which states that the more precisely we know the position of something, the less we know about its momentum. At these unfathomable densities, the very atoms of space resist further compression with a strength that exceeds gravity, causing the entire cosmos to rebound like a squeezed rubber ball. This moment of the bounce is the ultimate bridge, a fraction of a second where the arrow of time might be momentarily scrambled before pointing outward again. Current models suggest that this bridge is surprisingly robust, allowing certain large-scale features of the previous universe to survive the transition. While the fine details of individual stars or galaxies are lost in the heat of the bounce, the overall distribution of matter and the fundamental constants of nature might be preserved. This means that the seeds of our galaxies, the tiny density fluctuations we see in the cosmic microwave background, could be the survivors of a cosmic cataclysm that occurred before our Big Bang. Scientists are currently using supercomputers to simulate these quantum bridges, looking for specific signatures that would distinguish a bounced universe from one that simply inflated from a singularity. One such signature is a specific type of non-Gaussianity, a subtle non-randomness in the temperature fluctuations of the ancient sky. If our universe began with a bounce, the patterns of the hot and cold spots would contain a very specific memories of the collapse phase, a mathematical fingerprint left by the quantum bridge. This research is pushing us toward a new understanding of the beginning as a state of maximum density rather than a state of zero size. It suggests that the bridge is not just a mathematical trick, but a physical reality that connects our eon to the one that came before, ensuring the continuity of the cosmic story. As we contemplate this bridge, we realize that we are the product of a universe that refused to disappear, a cosmos that found a way to turn an end into a new beginning through the sheer resilience of quantum geometry. The bridge is a place of profound transformation, where the old world is melted down and recast into the new, yet the fundamental essence of the cosmos remains, drifting through the cycles of time with a quiet, persistent energy that we are only just beginning to decode. In the high-dimensional landscape of string theory, Our entire three-dimensional universe might be thought of as a single membrane, or brain, floating within a much larger, higher dimensional space known as the bulk. This perspective gives rise to the Ekpyrotic model, a term derived from the ancient Greek word for conflagration, which envisions the Big Bang not as a singularity, but as the result of two such brains slowly drifting toward each other and eventually colliding. Imagine two vast parallel sheets hanging in a breeze. As they sway, they occasionally touch, and in that moment of contact, a tremendous amount of energy is released across the entire surface of the sheets. In this model, the before was a period of vast cold emptiness where our brain was slowly being pulled toward a hidden partner brain by a weak inter-brain force. As they approached, the vacuum energy between them caused them to flatten and smooth out, explaining why our current universe appears so uniform and flat in every direction we look. This collision does not happen at a single point, but across the entire extent of the brain simultaneously, meaning there is no center to the expansion, just a universal surge of energy. Unlike the chaotic explosion of a traditional Big Bang, the Ekpyrotic bounce is a controlled rhythmic event that can repeat indefinitely. After the collision, the brains rebound and begin to move apart, and the energy released causes the universe on our brain to expand and cool, eventually leading to the formation of stars and galaxies. Over trillions of years, as the universe continues to expand, the matter is spread so thin that the brain becomes empty once again, setting the stage for the next cycle when the inter-brain force eventually pulls the sheets back together for another touch. This cyclic process offers an elegant solution to the problem of cosmic beginnings by suggesting that the before was a long period of contraction and preparation, where the seeds of structure were planted by quantum fluctuations on the surfaces of the brains as they drew near. One of the most fascinating aspects of this theory is how it handles gravity. While light and matter are trapped on our three-dimensional brain, gravity is a force that can leak into the higher dimensional bulk. This could explain why gravity is so much weaker than the other fundamental forces. It is being shared across dimensions. As we investigate these higher dimensional echoes, we are looking for a specific pattern of gravitational waves in the cosmic microwave background that would differ significantly from those predicted by the standard inflationary model. Specifically, the Ekpyrotic model predicts a blue-tilted spectrum of gravitational waves, where the signals are stronger at shorter wavelengths, a distinct signature that next-generation observatories might be able to detect. This vision of the cosmos as a rhythmic dance of membranes suggests that our reality is just one layer of a much deeper, more complex structure, where the bang is merely a heartbeat in a higher dimension. There is an intricate beauty in these depths, and for more moments of chill science, you are invited to stay and relax with us. The Ekpyrotic model invites us to imagine a universe that is never truly destroyed, but simply reset, a cosmic cycle that ensures the continuity of existence across unimaginable stretches of time and space. The silence of the bulk is not a void, but a reservoir of potential energy, waiting for the next slow approach, the next gentle collision, and the next brilliant reawakening of light and life in a new eon. As we drift further into the abstract reaches of cosmic history, we encounter a profound mystery etched into the very fabric of the oldest light, a vast, anomalous region known as the cold spot. This giant bruise on the cosmic microwave background is a region of space approximately 1.8 billion light-years across that is significantly colder than the surrounding areas. It is a deviation from the otherwise uniform temperature of the early universe that current models of random inflation struggle to justify. While some scientists suggest it could be a massive supervoid where matter is exceptionally sparse, others see it as the first tangible evidence of a universe that existed before or alongside our own. One compelling hypothesis suggests that the cold spot is a bruise on our cosmos, a relic of a collision between our universe and another bubble universe in a vast chaotic multiverse. If our Big Bang was just one of many, the interaction between these expanding bubbles could leave behind circular imprints, like two soap bubbles touching and leaving a mark where their membranes meet. Such a collision would have occurred before the light of the cosmic microwave background was even released, embedding a permanent signature into the temperature fluctuations we observe today. This concept shifts our perspective from a lonely, isolated cosmos to one that is part of a complex, interacting ecosystem of universes, each with its own history and perhaps its own laws of physics. The cold spot serves as a silent sentinel, a potential window into a pre-Big Bang reality where the boundaries of our space were not yet defined. When we look at this anomaly, we are not just seeing a lack of heat, but perhaps a literal shadow cast by a neighbor whose presence was felt in the high-energy environment of the early expansion. This pushes the boundaries of research as scientists use complex statistical models to determine if this feature is merely a 1 in 100 fluke of probability or a smoking gun for a new cosmological paradigm. If it is indeed a relic of a collision, it implies that the before was populated with other structures, other bursts of energy, and other timelines that are forever hidden from our direct view. As we study the cold spot, we find ourselves in a state of scientific drift, where the solid ground of the standard model begins to soften, giving way to a more fluid and mysterious understanding of our origins. The scale of the cold spot is so immense that it challenges our ability to visualize it. It is a void so large that thousands of galaxies could fit within it, yet it remains almost empty. Letting the mind settle into the rhythm of the ocean, subscribe to keep this stillness close to you. Rest well. This anomaly invites us to consider that the universe we see is just a fragment of a much larger, multi-layered story, where the beginning was not a clean slate, but a moment of intersection. The coldness of this spot is not a void of meaning, but a reservoir of possibility, suggesting that the echoes of what came before are not just mathematical abstractions, but physical realities we can map and measure. It represents the limit of our current understanding, a place where the map of the universe ends and the exploration of the beyond begins. This reminds us that even in the most well-studied regions of the sky, there are still whispers of an ancient and unknown heritage that predates the very stars. To understand how a universe might exist before our own, we must address the law of entropy, which dictates that in any closed system, disorder must always increase over time. This poses a significant challenge for cyclic models. If the universe bounces or repeats, why doesn't the entropy from the previous cycle accumulate, eventually leading to a heat deaths where no more work can be performed? In a truly eternal cycle, the entropy should theoretically be infinite by the time our eon began, yet we observe a universe that started in a state of remarkably low entropy, a highly ordered beginning that allowed for the complexity of life to emerge. This mystery leads us to the concept of the entropic reset, a mechanism by which the universe cleanses its ledger before a new cycle begins. In conformal cyclic cosmology, this reset happens through the geometry of space itself. As the universe expands toward infinity, the very concepts of distance and time lose their physical meaning. At this point, the universe becomes conformally invariant, a state where big and small are indistinguishable. This mathematical transformation allows the entropy to be pushed to the boundaries of the universe, effectively resetting the scale so that the start of the next cycle begins with a fresh, low entropy state. It is as if the universe, in its final moments of absolute cold and expansion, forgets its own size and complexity, collapsing the vastness of an old cosmos into the pinpoint of a new Big Bang. This process is not a violation of the laws of thermodynamics, but a radical reinterpretation of how they apply at the scales of eternity. Other models suggest that the expansion of space itself acts as a cosmic diluter. As the universe expands by a factor of trillions during each cycle, the entropy density becomes so low that it is virtually zero in any given region. When the bounce occurs, the new matter and radiation created are essentially clean, born into a vacuum that has been emptied by the sheer scale of the previous cycle's growth. This suggests that we are living in a universe that has a way of renewing its youth, a cosmic fountain of rejuvenation that operates on timescales of trillions of years. The wonder continues as we drift, subscribe, and stay connected to the quiet pulse of our world. As we ponder this reset, we realize that the information of the previous world might not be entirely lost, but rather heavily filtered. Only the most fundamental patterns, the largest fluctuations in gravity, might survive the transition, leaving behind the subtle echoes we now seek in the cosmic microwave background. This entropic cleansing is what makes a before possible. It provides the mechanism for a universe to have a history without being burdened by the weight of an infinite past. We are the inhabitants of a fresh start, a new chapter written on a page that was washed clean by the expansion of the world that came before us. This cycle of build-up and reset suggests a deep, underlying balance in the nature of reality, where the drive toward disorder is matched by a geometric capacity for renewal, ensuring that the dance of creation can continue forever. As we delve deeper into the quiet mysteries of the pre-Big Bang era, we move beyond the light of the cosmic microwave background to search for an even more ancient and elusive messenger, primordial gravitational waves. While light was trapped in the opaque plasma of the early universe for its first 380,000 years, gravity has been free to roam since the very first trillionth of a second, and perhaps even before. These waves are not particles of light, but ripples in the actual fabric of space-time, stretching and squeezing the geometry of the universe as they pass. In a cyclic or bouncing universe, these waves act as a fossil record, preserving the violent history of a previous collapse and subsequent rebound. Future space-based interferometers will sit millions of kilometers apart in the silent void to filter out the noise of our own galaxy, the dust and magnetic fields that mimic the cosmic signal. If the Big Bang was a singular event followed by rapid inflation, it would have created a specific signature of tensor modes, a particular twisting pattern in the polarization of the oldest light known as B modes. However, if the universe underwent a bounce, the spectrum of these gravitational waves would be fundamentally different. In a matter-bounce scenario, where a large, contracting universe full of dust and gas reaches a quantum limit and rebounds, the gravitational waves produced would be much weaker at the scales we can currently measure. Instead, they would hold a blue tilt, meaning they carry more energy at higher frequencies. This is the ultimate cosmic archaeology. We are attempting to hear the ringing of space-time caused by events that predated the existence of atoms. Detecting these signals is one of the greatest challenges in modern science, requiring ultra-sensitive telescopes at the South Pole and in high-altitude deserts. As one mystery fades, another waits. Subscribe to find your stillness here with us. If we were to find these primordial gravitational waves, they would provide a direct window into the bridge between eons, revealing whether the universe was born in a chaotic burst or a rhythmic bounce. The existence of these waves suggests that space itself has a memory, a physical capacity to vibrate with the energy of its own past. We are living in the wake of those ancient tremors, drifting through a space-time that is still subtly oscillating from the impact of its own rebirth. This realization brings a profound sense of continuity. The very gravity that holds us to the Earth and keeps the Moon in its orbit is part of a universal field that may have carried the echoes of a billion previous worlds. The search for these gravitational fossils is a testament to human curiosity, a reaching out into the deepest silence to hear the heartbeat of an eternal universe. It is a rhythm that connects the smallest subatomic scales to the vastest reaches of the cosmic horizon. As we drift further into the abstract regions of cosmological thought, the idea of a single universe, even a cyclic one, begins to give way to the more expansive concept of the multiverse. In this vision, what we call the Big Bang was not a universal beginning, but a local event within a much larger eternal background called eternal inflation. Within this vast, ever-expanding sea of energy, small pockets occasionally stop inflating and settle into stable bubble universes, each with its own Big Bang and its own set of physical laws. If this model is correct, the before of our universe was a state of high-energy vacuum that had existed for an indefinite period, and our cosmos is just one of an infinite number of bubbles floating in this cosmic foam. This shifts our understanding of echoes from being legacies of a previous time to being signatures of contemporary neighbors. Imagine our universe as a bubble in a boiling pot of water. As it expands, it might bump into another bubble. These bubble collisions would leave circular patterns of temperature and polarization in the cosmic microwave background, very similar to the Hawking points predicted by Penrose, but with a different statistical signature. Scientists are currently using sophisticated algorithms to scan the Planck satellite data for these cosmic bruises, looking for evidence that our universe is not an isolated system, but part of a vibrant, interacting ecosystem of realities. This perspective introduces a new kind of uncertainty language, as we must grapple with the fact that we can only ever observe a tiny fraction of this total structure. The echoes we search for might be the subtle tug of gravity from a neighboring universe that lies just beyond our light horizon, a phenomenon sometimes referred to as dark flow. This suggests that the large-scale motion of galaxy clusters might be influenced by the mass of a world we can never see. The wonder continues as we drift, subscribe, and stay connected to the quiet pulse of our world. Thinking of the cosmos as an ecosystem of bubbles provides a sense of profound scale and interconnectedness. It implies that space is not a vacuum of nothingness, but a fertile ground for the constant birth of new worlds. Our Big Bang was simply the moment our specific bubble nucleated and began its own journey of expansion, cooling, and structure formation. This model resolves the question of what happened before by suggesting that the background state of the multiverse is eternal. It has always been there, and it will always be there, constantly producing new universes in a majestic, never-ending display of creative energy. As we settle into this idea, the loneliness of a finite universe dissolves into the richness of an infinite one, where every possibility is realized somewhere in the vastness of the foam. We are the inhabitants of a single bubble, looking at the thin, glowing membrane of our origins and catching faint glimpses of the vast, churning sea that lies beyond our reach. We have traveled from the bright, mottled surface of the first light to the theoretical edges of higher dimensions, and now we find ourselves back in the quiet center of the present, looking out at a universe that feels vastly different than when we began. The concept of a beginning, once a sharp and jagged edge of time, has softened into a rhythmic pulse, a cosmic breathing that suggests we are not the first, nor will we be the last, to look up at the stars and wonder. This transition from a linear bang to a rhythmic void is a shift in the very soul of science, moving us away from the anxiety of a finite existence and toward the peace of an eternal process. In this resolving closure, we consider the possibility that the vacuum of space is not an empty stage, but a reservoir of memory, a field that has carried the vibrations of countless previous eons. If the universe truly follows a cyclic or rebounding path, then the atoms that make up your body are the refined products of an infinite heritage, recycled through the fires of successive cosmic rebirths. This realization brings a profound sense of belonging to the fabric of reality. You are not an accidental visitor, but a manifestation of a persistent, self-renewing system that has perfected the art of existence over trillions of years. As we let go of the need for an absolute first cause, we find that the laws of physics themselves may be the result of a long evolutionary journey where each bounce fine tunes the constants of nature. The strength of gravity, the speed of light, and the mass of the electron may be tuned to create a cosmos increasingly capable of complexity and consciousness. This cosmic natural selection suggests our universe is uniquely suited for life. The silence we hear in the deep void between galaxies is not the silence of a tomb, but the stillness of a deep, restorative sleep between breaths. In this stillness, we can find a sense of peace that matches the scale of the stars, a quiet recognition that the universe knows how to begin again, even when everything seems to have reached its end. The echoes we search for in the light and the gravity are the whispers of our own ancestors, reminding us that the story of the cosmos is one of resilience and continuity. As our exploration concludes, we see the Big Bang not as a violent explosion from nothing, but as a graceful transition, a moment where the old world offered its energy to the new in a majestic, silent handoff. This view of the universe as a perpetual, rhythmic entity offers a sense of resolution. We are part of an endless dance, a cycle of light and dark that ensures the flame of existence is never truly extinguished. The universe does not fear the dark of the future because it has survived the dark of the past an infinite number of times, returning with new stars, new galaxies, and new possibilities. As we settle into this final stillness, we carry with us the understanding that the horizon is not a wall, but a doorway, and that the echoes of the before are the promise of an after. We are the observers of this grand, rhythmic void, the ones who give a voice to the silent history of the light. Letting the mind settle into the rhythm of the ocean, subscribe to keep this stillness close to you. Rest well. The journey through time and space always returns us to ourselves, but transformed by the knowledge that we are woven into a tapestry that stretches forever in both directions. The cosmic microwave background, the gravitational waves, the anomalies in the cold spots. These are the fingerprints of a universe that is alive with history and potential. As you drift into a deep and restful sleep, let the thought of the eternal cycle be a comforting weight, a reminder that the universe is a safe and steady home that has always existed and always will. The night sky is no longer a mystery to be solved, but a presence to be felt, a rhythmic, glowing witness to the fact that there is no end, only the next beautiful beginning. In the grand silence of the pre-Big Bang era, we find the ultimate chill science, the knowledge that the universe is at rest because it is simply following the natural, ancient beat of its own heart. We are the children of the bounce, the heirs to the eons, and in this quiet moment, we are exactly where we are meant to be, floating in the gentle, cooling afterglow of an infinite story. As the light fades and the thoughts settle, the universe continues its slow, majestic expansion, carrying us forward into a future that is already written in the patterns of the past, a future as certain as the dawn of a new cycle.